Hey everyone, Mr. Voikin here. This is lesson 2.5 and 2.6 put together. We're talking about ratios and equivalent ratios. So these two go hand in hand. You can't learn about ratios without understanding what an equivalent ratio is anyways. So what is a ratio? Well, it is a comparison of two or more quantities. Now, what does that mean? Well, I've got an example of it right here for you. So you can see below we've got a bunch of apples and we have a bunch of grapes. So I'm just going to go grab all these apples and sort of put them together. Okay, so there we go. I'll move that grape out of there. We'll put it over on the other side. So we got apples on one side and we got grapes on the other side. So basically, they will state how you want to compare them. Okay, and essentially, if they say we're going to compare them and set up a ratio of apples to grapes. So if it's set up like that, what is the ratio of apples to grapes? We just count them out here. For apples, we got 1, 2, 3, 4, 5, 6 apples. And for grapes, what do we have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 grapes. So the ratio of apples to grapes is 6 apples to 8 grapes. So it's 6 to 8. Now that can also be put in fractional form, 6 to 8, like that, 6 over 8. So either of these is fine. But like any fraction or a ratio in this case, we need to make sure it's in its lowest, simplest form. So 6 and 8, they have a common factor of 2. So I can divide 2 into the 6 and get 3, and I get 8 divided by 2 is 4. So the ratio is going to be 3 over 4, or 3 to 4, rather than 6 to 8. Okay? Now, what if they said, well, what is the ratio of grapes to apples? Okay, well, in that case, it's going to be grapes to apples, the two dots right there, which is a colon, is how we set it up. Grapes, in this case, is 8, and 2 apples, 6, or we can put that as 8 over 6. And again, we're going to reduce that down because we can divide 2 into everything, and we're going to end up with 4 to 3, or 4 over 3. Okay, so really how this is set up right here is going to be very important in our setup down below. Okay, let's take a look at another example, and it says, what is the ratio of, well, we've got 4 things to choose from down below. 1, 2, 3, 4. And we're going to use this diagram right here to answer those 4 sort of questions. So it says colored sections to total sections. Now it looks like they're all colored in green right now, but I'm just going to take a green color and sort of fill them in like that. Okay, so we'll say I'm going to make it like that, 4. Okay, so there are 4 colored sections. Those little squigglies represent the colored sections. And how many total sections do I have? Well, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So basically what I've got is 4 colored. I got 16 total, which means that I got 12 that are not colored. So that's the information you need to extract at the beginning before we start figuring out the ratios. So the first one is saying, well, what is the ratio of colored sections, so colored, to total sections? Okay, so again, what is the colored section? It is 4. 2, what is the total? 16. Then I ask myself, well, is there an equivalent ratio in its simpler form. And yes, I can divide 4 into 4, and I can divide 4 into 16. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So even though this one is technically correct, this is the answer we'd be looking for if you want to get full marks. Okay, the second one says colored sections to non-colored sections. So I've got colored, just going to grab the red here, colored to non-colored. And what is the colored? It's 4. What is the non-colored? It's 12. And again, I can see I can divide 4 into both of those. So the equivalent ratio in its simplest form would be, whoa, where are you going? 1 and 4 divided into 12 3 times. So 1 to 3 is the ratio of colored to non-colored sections. And the next one says non-colored to colored. So it's essentially like the one we had above that was colored to non-colored, except in this case they're just reversed. So I've already got the answer sitting right here, 1 to 3, except it's going to be in reverse. So it's going to be 3 to 1. Okay, and the last one is basically saying non-colored. So non-colored to total. And again, what is the non-colored? It's 12. And what is the total? It's 16. Again, I can divide 4 into both those. 4 goes into 12 3 times, and 4 goes into 16 4 times. So again, the best answer would be this one in its simplest form. Okay, so moving along, I've got a bunch of circles of different colors and sizes. Okay, so what is the question asking us to do? We want to figure out a ratio of blue to red to green circles. So the size doesn't matter, it's essentially the color. So I'm just going to make a little chart right here, and so I got blue, and I've got red, and I've got green. So let's start off with the blue. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 blues. You have to be careful with the counting. It's easy to miss one or double count. Okay, and we'll go to the reds. We got 1, 2, 3, 4, 5, 6. So I got 6 reds. And finally with the greens, I got 1, 2, 3. So what is it asking us to do? A ratio of blue. So what I want is to keep it in that order. Blue to red to green. Okay, and I just look here. Blue is going to be 9 to the red, which is 6, and finally to the green, which is 3. So the ratio is 9 to 6 to 3. Now again, can this be put in simplest terms? Do all 3 of these have a common factor? Yes, 3 can divide into all of those. 9 divided by 3 is 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. So the best answer is going to be this one right there, which is put into its simplest form, 3 to 2 to 1. Okay, now I'm just going to push this up here and look at the second part of this question. If the ratio above remained the same, so it's going to remain the same. So it's going to be 3 to 2 to 1. That's going to be the ratio of blue to red to green. Okay, now it says that how many blues would I have? So it's like this is sort of our unknown. I don't know how many blues I'm going to have, so I'll put an X. And red, we don't know that, so I'll call that Y right now. Now really I could have actually probably called it a B for blue and a R for red, but it tells you we have 9 green. So you got to look at the ratio between these two right here, because those are the only two numbers that I have to work with. Okay, so if the ratio says that there is 3 blues, 2 reds, 1 green, but I have 9 greens, if I keep the ratio the same, how did I go from 1 to 9? Well, we're not going to use the addition plus 8. We're going to use the multiplication. So it was times 9. There are 9 times as many green circles in the second scenario. So I have to do the same thing for all 3 to keep it equal. I'm going to multiply this all by 9. So essentially what I end up with is 3 times 9, which is 27, to 2 times 9, which is 18, and the last one was 9. So the answer to this question, we got to make sure we're answering the question. It's not asking for a ratio to be set up like this. It's saying how many blue and red circles would you have? And the answer is you would have 27 blue circles and 18 red circles if you had 9 green circles. Okay, so that is the perfect response to this question right there. Okay, and that's it for these 2 lessons. So in class, we will work on the questions out of the textbook. See you in class.